Hello, this is checkpoint 2.45. They want us to find the distance between the point 036 and the line. And the line is given by x is equal to 1 minus t, y is equal to 1 plus 2t, and then z is equal to 5 plus 3t. Let's get the idea behind the formula first of all. Let's imagine we have a line in space somewhere, and the line is given by, and we can extract the point and the direction that this is moving. In fact, for this line, why don't we do that now? We have the point 115. If we look at the coefficients or the constants that don't have a t in them. So let's call this point, and that was 115. And then the direction vector is going to be, it's going to end up being the coefficients of t, because remember it's point plus t times the direction, and the direction vector, let's call the direction vector d for the direction, and that is going to be given by -1, 2, 3. Okay, now you have a point that's outside of the line. Let's put the point somewhere over here. And again, this is not being drawn to scale, of course. We're just kind of piecing through the formula. Let's call this point P. But more important than the point, and the way they decide that they wanted to do this distance, when you're looking for this distance, and the distance that we're looking for would be the perpendicular drop here. We're looking for that distance. And the way they do this is that they create a vector connecting these 2 points. And maybe we'll call that vector V. And by coming up with that vector, what they would like to do is create a parallelogram that connects these 2 vectors. And we know from last section that the area of this parallelogram is going to be the magnitude of the cross product of V and D. So we know that the area of the parallelogram would be the magnitude of the cross product of those 2 vectors, V and D. Now, geometrically, we also know that the area is going to be the base times the height. Area equals base times height. And the height is exactly what we're looking for. So if we take this area, base times height, and divide by the base, we're going to get the height by itself. Height is equal to the area divided by the base, based on this that equation. But what is the base? The base is D. And what is the area? The area is the magnitude of the cross product. And so there is our formula. This is equal to the area, which is the magnitude of V cross D, divided by the length of D. Okay, so based on that picture, we have ourselves a formula. And so now we just have to identify those pieces. It looks like we have P, and we have the D that we want, so we need V. What was that point again? That point was 036. And we need to find the vector V. So our V is going to be the difference between these 2. Now it really doesn't matter which one, but according to the picture we should draw the P vector minus this point that we got. Oh, they're both labeled P. Let's call this one Q. Just to give it a name. It doesn't really it's not necessary to give it a name, but the vector v is what's important. So it's going to be 0, 3, 6 minus 1, 1, 5. And then let's go ahead and do that and get our vector. So that's negative 1. That's 3 minus 1 is 2. 6 minus 5 is 1. All right, we have a vector v, we have a vector d. Let's find the cross product. Let's do the cross product v cross d. Now the order really wouldn't matter because we're going to take the absolute value anyways. Cross d, so let's go with that. And determinant way of doing the cross product, a, j, k in the first row and negative 1, 2, 1 second row, and negative 1, 2, 3 d in the third row. All right. In the I direction, it's going to be 3. That's 6. 6 minus. In the j direction, it'll be negative 3 minus negative 1. So it's negative 3 plus 1. But then there's a negative. So let's do that. And then in the k direction, it's negative 2. So that's going to give us and we take the magnitude. Let's call this the area of v cross d. Give us the square root of 4 squared, 2 squared, and that's a square root. So that's our numerator. That's now we just need our magnitude of d, and that is the square root of squared plus 2 squared plus 3 squared. And so that's 9, 10, 14, and that's what we have. So now let's find our distance. Our distance is the a divided by b, so the area, the magnitude of the cross product divided by the magnitude of d. So the height, the distance, let's call this distance, is going to be h, the height that we're calling h, which is a over b, and a was equal to square root of 20 over b, which is square root of 14. Okay, I suppose that's good, and I suppose you can also simplify just a tad bit. They're both divisible by 2, so that's 10 over 7. We can put it all under 1 square root. Okay, that's it. I hope that helps.